Welcome. My name is Joris van Bossche. I'm from Ghent University. I'm going to give an introductory talk about Pandas. So yeah, that's a little bit about me. I'm a PhD student at Ghent University. It's in Belgium, and I'm one of the core developers of Pandas. A little bit about this talk. I will just give a brief introduction about the different data structures in Pandas, and then show some more advanced features based on a case study. This talk is a notebook, so if you want to follow along in the notebook or you want to look at it afterwards, you can always, at my GitHub page, just my name and then the repository for this talk. There you can download the notebook, the data I use, and there's also a link to the MB viewer if you just want to look at it. The standard imports, but I'm going to start with a little showcase. The case study I'm going to use, I will give an introduction later. It's about air quality data. I just took this one because it's my field of research, but of course a lot of the things I will show you can apply on other data sets as well. What I have here is a time series of hourly air quality measurements of nitrogen dioxide and just different stations. And what I want to show is that with Pandas, with just a very few lines of codes, you can answer interesting questions about your data. You can gain insight into your data. Just for example, with one line, I want to know, is there the decreasing trend in the yearly averages in the pollution? You see, it's a very small decrease. Or there are European limit values. Do they exceed the limit values, and how many exceedances are there? Also, again, very easy to do this with Pandas. Or where the daily profile, the diagonal profile, is different in the week or the weekend. Again, just with a few lines, it's very easy to obtain this. And I will come back on these examples later in the talk. I will go step by step how I did obtain them. So, but first, a very broad introduction about Pandas. Why do you need Pandas, or when do you need Pandas? It's mainly when you're working with structured data, like an R data frame, a SQL table, a database table, an Excel spreadsheet, are typical examples of also structured tabular data. And you can use Pandas to import them. Pandas has a lot of flexible and easy to use import and export functions for a lot of different formats. But to clean up your data, maybe your messy data, to reshape them, to prepare them for an analysis, to prepare your data for later use it with scikit-learn or stats models or things like that. So in Pandas, you can think of Pandas as it's based on NumPy arrays, but it's providing labels to those NumPy arrays, and also has support for heterogeneous data types, which is not possible in NumPy. And you can also see it as the typical example of the data frames, but then in Pandas, and then with, of course, with the whole Python ecosystem around it. Some of the key features, but I will show later on, just show it with some code. But I already said it, the import-export functionality, also working with missing data, very powerful time series manipulation functionality, all the reshaping, merging, things like that, and also some easy, quick plotting functionality. So, but the basic data structures, what are they? So you have the series and data frame object. I will go rather quickly through this because I think it's, if you were somewhere familiar with Python and NumPy, it's rather easy. So the series, what is a series? series is just a one-dimensional. You can look at it as a one-dimensional NumPy array, but then provide with some labels, and you get, if I can use this one, you get a between a label and the value. So those labels and values, you can access them as they are called the index. The index will give you all the labels, and the values attribute gives you back a NumPy array with the values. You can also access them just with indexing, but that's of course one of the strengths of Pandas. You don't need to use just an integer index as you would do with NumPy, but you can provide some, for example, string index or a lot of other possible indexes. In this way, you can look at the series object. It's actually like a dictionary. Here I give an example, just some countries with the population in millions of people, and you can look at it as a dictionary, because you can just, this looks the same as you would do with a dictionary, but you have the power of NumPy arrays that you can, for example, do the vectorized operations, which would not be possible with dictionaries, of course. Also, more advanced indexing, not really advanced, but you can slice, you can do some, you can index with lists, you can index with Boolean indexing, and things like that. For the rest also, you have the element-wise operations. You have a lot of methods, just like on NumPy arrays. You have a lot of methods available. Think of the mean, median, standard deviation, all the standard methods. So one thing that's special and that you have to be aware of with Pandas, because you have labels to your data, when you do operations of them, here is an example of just an addition of two series. Pandas will always try to match the labels. It's called alignment. So if here's a small example where the labels, I just took two subsets of the population series, and if I have two series with not exactly the same labels, you will see in the result only the common labels will get a value. So then the data frames is then what you will use the most. It's the 2D structure. It's a bit the same as a series, but now you have two. It's a 2D, so you have the index is the same, but you now have also the columns attribute. So in this case, and it's also in these notebooks, it's formatted as a nice HTML table. So here you have the four columns, and these are the index labels. Again, you can access these attributes as the index and the columns. You also have a dtypes attribute, which gives you different dtypes of this data frame. You have the info method, which gives you an overview of the data frame, what index does it have, the different columns, different data types of those columns, different how many values, and things like that. And again, you can access the underlying NumPy representation through the values attribute, but beware that if you have heterogeneous dtypes in your data frame, it will be upcasted, and in this case to an object array. If you only have, for example, integers in your data frame, the values the NumPy array will just be an integer with an integer dtype. You can, for example, I want the countries as my index. You can easily set one of the columns as the index. You can also access one of the columns in your data frame. That will give you a series. You can easily do calculations with those columns. For example, take here the population divided by the area to have the density of the countries, and assigning, adding a new column is just assigning to a new label, and then you have a new column added to the data frame. And then again, you can use the some things as Boolean indexing, just as you would do with NumPy arrays. Yeah, there are of course a lot of methods available, but it's if you you can look up them in documentation, or if you tap complete on a data frame, you will get a huge list. And this is just an example that you can also sort based on a certain column. Then another useful method is the describe method, which just gives you a basic summary of some statistics, given the number of values, the mean, and some quantiles. The data frame has also, you can also quickly, just to explore your data, quickly plot some of your data. In this case, okay, I used here just plot. Default are line plots, and in this case it's not a useful plot to show, but for example, if I say I can specify a certain kind of plot, and we have some baked into Pandas, for example, a bar plot of the population in this way, or I can scatter plot between the population and the area. So it's it's of course not as powerful as just matplotlib, but a quick way to visualize some things, and it's also you can integrate it with a more advanced matplotlib plotting. I'm going to skip this one, but just showing these are the basic data structures, but I'm just going to show you now with a case study that you can really, the Pandas is a really powerful library to just look at your data, to manipulate them, to prepare them, and things like that. So the case study, it's the AirBase database. It's a database of the European Union, of the Environment Agency, that includes all data of the monitoring stations around Europe. Added here one. I used data of 2 stations nearby. There are those 2, for those who are familiar with Paris. Yeah. So the first thing, if I want to start with my data, I have to import them and clean them a little bit. As I already said, Pandas has built-in import and export functions for a lot of different formats. I listed here some. You can always just look at the if you look at the tab completion, you will see all the possibilities. There is easy import. You can just SQL database. It's based on SQL Alchemy. So all databases that are supported by SQL Alchemy you can use, but also the HDF5 format you can read, and a lot of other things. Also, just an Excel file. It's also supported if you have the correct dependencies. And similar, so all the import functions are read, and then something, if you want to export to the same format, it's your data frame, and then the format. For our case study, I downloaded some of the data files from AirBase, and I downloaded some data for nitrogen dioxide. It's a typical pollutant, and for some different stations. But my data look like this. So I showed here one line of the first line of the data file, and you see that it's structured as I have a date, and then I have my 24 hours as one row. It's a typical data format that you see a lot and not a lot. It's not really a very handy format to analyze your data, but it's like that. So to read it in, I can use the read CSV function, and if I provided that's a tab separated, so that's a tab separated file, and if I just use read CSV, I get this data file. But of course, it's not really what we want. So I provided some more options. I said there is no header in my file, so I want to provide some column names myself. I made up some column names here, and I also set for all the values that are minus 999 and the 9,999 that should be interpreted as not available as non-values. So if I specify it over there, then at once all those values are represented as nans. So this is already looking better. For now, I disregarded the flag column. So if I drop it with the drop method, I end up with this one, this data set. So I have a date column, and then I have 24 columns with the different hours of the day. So to do some time series analysis on this, it's not really a handy format, and I will have to reshape it to a time series. So for that, I short intermezzo about reshaping your data with stack, unstack, and pivot. The documentation of Pandas gives a very difficult explanation of what unstack does. But basically, if you have something like this, you have a data frame with different columns. So all the functionality that you want to do with those functions is shifting between one of those two formats. So in this case, I have here a column with values, and I want that this column in my other format, here is one column. I want that this will become my column names. So that's so from a long to a wide format actually. So this reshaping. So you from this you unstack or you stack. From this one to here is stacking. You can do with those functions. So to use the same data frame as in the output, as in the picture, we have this one. So this is the data frame we start with. What is important to know with stack and unstack, you always need the columns or the values you want to shift from the row to the column or the other way around. You need it as index values. So I set here the A and the B column as the index. So I get something like this. Now if we unstack, then by default, so by default, if I say unstack, I will do one of these values to the columns, and it's by default it's the last level of the index. So with unstack, the A and the B will go to the columns, like you see over here. Then the other way around, you can do it then with stack. The reason I used here reset index at the end is because otherwise, yeah, it would be a series and I wanted it as a data frame. But so pivot is actually something similar, but here it's a little bit less flexible, but it's maybe easier to use, as you can just indicate which columns you want to use as the index labels, as the column labels, or as the values in the data frame itself. Then a last function that is related to this is the pivot table function, and this is actually so it's the same as pivot, but it can handle different if there are duplicates in the data set. For example, in this case, if I want to put my A as the row indices and the B as the column indices, there are multiple times, for example, here we have 1A and 1A. So if you just use pivot, it doesn't know what to do with those multiple values. If you use pivot table, you can specify an aggregation function. So for example, here you have the count, but there are a lot of methods available. And you can, for example, also take the mean of those. And then you get the mean or some other functionality. Back to our case study, what we wanted to do. So our data, how did our data look like? If I set the, oh, this is not possible anymore, but I already did that. So our data looks like this. We have our dates and our hours. What we want to do, we want to bring these hours, just also to over here. So what is this? This is a stacking operation. So if I then call stack on this data, then you get the stack data, and you will see now I get a series with the date, and then for each date the different hours and the values. To further then process to something useful, I just combine the two levels at the date and the hour into a date time, so I can use it as a time series. So I end up with something like this, a nicely formatted for one station the different hourly pollution levels. So in this format, it's usable to do some exploration of the data and some analysis. For this talk, I put it in a separate file. I repeated this sometimes, and for different stations. For those who are familiar with Paris, I took the two nearby stations from this place, and also two stations from Belgium. So then, now I have my data in a nice format. Then the next step is I can explore some of the data. Therefore, you have different functions. For example, you have the head function. The default is to show you the first 5 rows and retain the last 5 rows, but you can also provide a number, how many rows that you want to show. Then again, I already told you about the info method. Here you can, for example, also see how many null values that you have in each column. You see already that you have more values for those two stations than the other two. So it's a summary of your data frame. Also already explained this, the describe function. You can quickly see, for example, that the mean, that this station here has the highest pollution levels. It's, by the way, logical because this is a traffic site station here in Paris. Quickly visualizing some data. For example, one of the plotting methods is also available on the data frame is the box plot. So you can see here again, this is the station with the highest values. For another example, I can quickly take an histogram of some data, or just plot the time series. This is a little bit less useful because you have hourly values for a lot of years, so you don't see much about that. You can, for example, take only the last part, but the next thing is looking at some time series to better handle the time series. So Pandas has some built-in useful functionality to really powerful to work with time series. So you just have to ensure that your index is a date-time index, so that your date times are not strings, but you can use the toDateTime function for that to convert, for example, datetime strings to a datetime. So that's important. But then it's really handy that you can use strings to index your datetime your data frame. So you don't have to use a real datetime because it would become rather long to type the object, but you can just use strings and they are interpreted like datetimes. So it's very easy to, like this, to index your data. What is something else that's really useful is that if you are doing string indexing, it's also working with partial strings. It's called partial strings. For example, if I say I want just the 1st of January of 2010, it will interpret as all data from the first hour up to the last hour of that day. From all data of that day. This also works with if you want to slice, it's the same. You can, for example, say, well, it's not that easy with one. For example, all my data from the 1st of 2000 up to 2011, you will see now the last days here are the last day at the 31st of December of 2012. So 11. So with those strings, it's very easy to just select your data within a time series. Yeah, so this is the partial that I already explained. Another thing is you have a lot of components available on the datetime index. For example, the hour, but I think most things are available. For example, you have you can also ask for the week or the week of the year. All possible things are available. For example, also the year. And so there are the different components of your datetime. And then something very useful is the resample method. So what is the resample method? This is for converting the frequency of your time series. So in this case, I have hourly data, and maybe I want to convert them to daily data. And this is very easy with the resample function. So what do? Your data frame, NO2, I resample them, and I just say, capital D denotes that I want daily data. And by default, it will take the mean of then all the hours in that day. You can specify the function you want. You can also, for example, take the minimum of that day, the maximum, the standard deviation, things like that. But by default, it will take the mean. So in this way, you can really specify what you want over here. You can also, for example, say, I want to resample every 10. You will see that now you have resampled every 10 days. So it's really quickly just changing the frequency of the data of the time series like that. So as I said, you can, for example, take the max and that's with the how keyword. Combined with some plotting, for example, now here I took a monthly means of the full data set. For example, if you want annual data, very easy, just like that. And now I have yearly averages for the full time series. So it's very easy to do some shifting in the frequency of your time series. And here's another example. I took, for example, the 2009 data of one of the stations. So this is with some indexing, all data of 2009 up to the end of the data set, it's 2012. For one station, I resampled monthly and I took the mean and the median and I plotted it. So then you see that the median is always a little bit lower in this case because you have a tailed distribution. So one of the pictures I showed in the beginning was what is the evolution of the yearly averages? So in this way, it's very easy to do this. Just resample annually and you plot it. And I added here also the overall mean of the 4 stations. And you see there is apparently a little bit of improvement in the air quality, but not that much, I would say. So, and then some more how to analyze your data with Pandas, some more advanced things. And therefore, I'm first going to explain what group by is. So group by operation, it's the split, apply, combine algorithm. So if you look at the picture over here, you have some data. So you first are going to split your data based on a certain key. In this example, we are going to split based on this column, A, B, and C. So you put all the A's together, all the B's, all the C's together. Then you apply a function to each group. This can be an aggregation function like here. You take the sum of each group, but it can also transforming. You can, for example, normalize data within each group. And then you combine the different groups together again to a data frame. So this is the group by functionality. This is you can do a lot of different kind of analysis with this one. For the showing how does it work in Pandas. So with this data frame, it's the same data frame from the picture over here. So what we did here, we said we want to group by the key and then take for each group, we take the sum. So how does it look like in Pandas? Very easy. You say you group by the key and then you take an aggregation, namely the sum. You can also, there are some shortcuts available. For example, and for the sum you can just do it like this. So the sum. And of course, a lot of different functions are again available here. For example, you can take the mean as well, and then, oops, yeah, this one is not, I didn't specify it. But, okay, back to our data. The next question, does a typical monthly profile look like for the different stations? So I want over all the different years, the typical monthly value for a certain month. You can't do that anymore with resample, but you can do that with group by. How do you do that? By actually you are going to group on the month attribute of your index. So in this case, you can, for example, first add a column named month, and then you do the, as we saw before, you have the month attribute on your datetime index. And then you just say, okay, I group by the month, and I take the mean of every group. So then you will get a data frame with the 12 months, and then a mean for each station. So combined with a plot, it looks like this, and you see that the air quality is a little bit lower in general in the summer months as in the winter months. Another question is maybe you want to know, not a typical monthly profile, but for one day, what is a typical profile during the day of the air quality for different stations. Then again, the same, you go by not by the month, but you go by the hour, and you take the mean, and we quickly plot it. And then you see something like this, the typical 2 peaks, the morning rush hours, the evening rush hours, as NO2 in this case is very related to traffic, so then you get a typical profile like that. Another question you could try to answer is, what is the difference between this typical profile we saw before, this one, but let's now divide this between weekdays and weekend days, because I said it's related to traffic, the typical rush hours, so we would think this would be different in the weekends. So for that, you have, for example, at the weekday attribute. Yeah, you only see zeros, but this will give a number of 0 up to 6 for the different days of the week. So we add it to our data frame, and then we say we are going to add a new column, and I say this weekend this will be true or false if it's in 5 or 6, denoting Saturday or Sunday, then this will be true if the weekday is in this list, otherwise it's false. So true is, false is for the week, true is for the weekend. You could, of course, rename the true and false to weekday and weekend. So, and then, very easy, you can group by on more than one key. In this case, I will group by on this new weekend column. So I take separately means for the weekend and for the week. And then the same as before, also on the hour. So I want for each hour, for both the weekend and the weekdays, the mean value. I did it here only for, yeah, so if you look at it, then you get something like that, the first rows. If you do it only for one column, for one station, I just select here one station, and as you saw before here, because you grouped by two different keys, you get here two levels of the index. First you have false, and then 0 to 24, 23, and then for the trues also 0 to 23. But for example, for plotting it, it's easier that you have just two columns, the week and the weekend. So in this case, as we saw before, you can, for example, use the unstack function to shift the false and true to this one. So now I have a data frame with false for the weekdays, true for the weekends, and the averages for all the hours. If we plot it, we get something like this. And you see, not that surprising, that in the weekend, people typically don't go out with their cars early in the morning, opposed to in the weekdays. So again, very quickly, with just some lines of code, you can quickly get some insight in your data, raise some questions, as well as transforming your data, preparing your data for further analysis on the different things I showed. From there, you can start, for example, with some applying some models to do some more advanced analytics. Another example I gave in the beginning was the question, okay, how many exceedances above the official European limit value do we have? For hourly values for NO2, it's 200 micrograms cubic meter. So very simple. I just, for our data set, I see just which value is above 200. This will be a Boolean data frame. And then I want to know this for every year, because Europe says, okay, you can have 18 hours where the air pollution exceeds this limit value. So I want to count the number of exceedances for each year for the different stations. So my exceedances, I just group by then by the year, and I take the sum in this case because it's our booleans. So in this case, we will have a count of them. And then what I did here is just plotting this one as a bar plot. The only thing is I had here still the month and weekend columns, but yeah, you should first drop them or select the correct ones. I will do it. Well, this looks better. So here you have a plot of the different exceedances. Just to quickly tell what you can see on it is that this is the limit of 18 exceedances, And the station in Paris, the traffic side station, is clearly, I would rather say, high, not really getting to the limits. Only the last year in 2012, the data are not really up to date. It's only up to 2012 that are online. The last year it was below, but probably it's not very significant for only 1 year. So again, some insight into the data. Yeah, maybe I don't know how my time is going. Another example is here I want to see the week profile as bug plots. Again, I can access some elements of the index, namely the weekday and the different weeks. And then I take, in this case, a pivot table. So I say I want the different weekdays, so from Monday up to Sunday as the columns. I want the different weeks over my full data set, so the 52 weeks of every year in my as the different rows. And for the values, it's not visible here, but I took the so one station, and I set by default it will take a mean of it, the pivot table. And if you then take a box plot of this, you get something like this. And you see in the weekend, on Saturday and Sunday, the air quality is a little bit better as in the week. So nothing, it's also just showing some things that you can also take some correlations on the different data sets. So I'm coming to the end of my talk. Of course, there are a lot of more things I could have shown about Pandas, what you can do with it. But I just showed some things on a specific data set, but all those, the application of pivoting, group by, also applied on all kinds of data sets. Here's the link to the documentation. You have also the famous Python for data analysis book of Wes McKinney, who is the original author of Pandas. There are also a lot of other tutorials on the internet. I just gave you one link to something. Some things that are some recent enhancements from the latest year is that there are now also some better support for categorical data, also for time delta data. As I said, the new more flexible SQL input-output functionality based on SQL alchemy, and a lot of other enhancement and bug fixes. But I also want to end my talk with that you can certainly, if you are a user of Pandas and you like it, that you can certainly help. Even if it's just very small, report some issues that you have, or you can maybe improve some documentation. But also very valuable is testing and release candidates and providing some feedback and other things. So you can, for the development of Pandas, you can find everything here on the GitHub page of Pandas. So yeah, that was it.